All right. In our previous lesson that we just did, we talked about converting from logarithmic form to exponential form. And we did a bunch of practice, and we also talked about um, the basics. If I have uh, any log um, with an argument of 1, we know that the exponent is 0. A to the power of 0 gives me 1. Any number to the power of 0 gives me 1. And whenever the base and the argument are the same, we know that our exponent is going to be 1. Okay, so the vocabulary that we used last time is we talked about the base, which is the blue thing here. The yellow thing is called the argument, and the pink thing is called the exponent. So if you should really put this on the top of your paper, maybe color code it like I am, because it will really help you. This is something that you should maybe write on the top of your paper each time. It will help with knowing this. So right now we're just going to do a little experiment here. We're going to type in log 2. What do we get? We get 0.301, and log 3, and what do we get? We get 0.4771. And let's see, what happens if we type in log 6? Log 6, we get 0.7782. And you should notice that this plus this gives me this. Okay, and I'm going to hit pause, or you should hit pause and try to do these on your own. Okay, now that you've hit pause and tried these on your own, you should have noticed that when I add these here together, we're going to get the same answer as here. So log 5 plus log 6 gives me log 30. Log 5 plus log 3 is going to give me log 15. So what we can deduce from this experiment, from this noticing and wonder, is if I've got log of something plus log of something else, we can write log of those two things multiplied by each other. This is called the product property. These laws of logarithms is very important in science and engineering, and colleges will expect that you know these log properties. Okay, so let's do part 2 of our investigation now. So if I go in my calculator and type in log 6, we know log 6 is 0.7782, and log 3, we know this is 0.4771, and if I do log 2, well, we already know that that is 0.3010, and I'm going to you should hit pause and try to do the next few yourself. Okay, now that you have hit pause, I'm going to show you the answers from the work that I did. And what you should notice is that when you've got log of something minus log of something else, you get the same results as if I did this value divided by this. 6 divided by 3 gave me log 2. Log 15 divided by log 5 gave me log 3. So this is called the quotient property for logarithms. It kind of works very similar as the product property. Okay, and we're going to be practicing both of these properties today. Okay, so we're going to learn and study one more property. Okay, use your calculator and investigate this here. Okay. 3 times log of 2 gives me this value, 0.903 1. Okay. And log 2 cubed gives me, dun, 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 oh my gosh, it's the same thing. Okay, I'm going to let you try these other ones on your own and hit pause. Dun, 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 dun. Oh my gosh, it's the same thing. So if I've got a number times a log of something, we can move this leading coefficient and it can become the power of this value here. And this is called the power property. So what we've just discovered in the last 6 minutes, or maybe a few minutes longer, is the product property, the quotient property, and the power property of logarithms. And these are things that will come in handy when you do calculus, for those going on to HL. These are useful properties. So the next bunch of questions are just applying the log properties. So you can see these 3 are done for you. I want you to hit pause and try to do the rest of the page yourself. Okay, I'm going to move this up so you can see this one here. Okay, now hit pause and try to do the next 3. Okay, good work. Here is the answers for these 3. Okay, hit pause and then try to do the next 3. Okay, so here are the next 3. Okay, so hit pause and try to do the next thing. Okay, so natural logs. Okay, so earlier we talked about natural logs. So E is approximately the value of 2.718. Okay, so what did we say before? So log base E of E. Now, on our property handout from yesterday, when the base and this are the same, we know that the value is going to be 1, isn't it? So we know that this is equal to 1. Also, what we talked about the other day is log base E. That's the same thing as writing natural log so if I didn't want to write this little subscript e, I can simply write natural log. Okay, and this is not a capital I. Okay, so so I guess in French it would be log natural. Okay, so oh yeah, it says over here in French, logarithme natural. Okay, so now they want you to practice these using our different laws. Okay, so here using the power rule, I can bring the 2 to the front and then log log base E, that's going to be equal to 1. Okay, try the next 3 on your own. Okay, there's the answers for that. Try the next three on your own, D, E, and F. Okay, here's the answers for those. Try the next three on your own. Here are the answers to those. And try the next three on your own. And here are the answers to those. Okay, is there more? Oh, there's more. But wait, there's more. Okay, these may be a little trickier. Okay, solve these. So what I'm going to do here is I'm going to write this as log base E x equals 2.7. Okay, so now I'm going to convert this to exponential form. So I can say my base E to the power of 2.7 is equal to the argument of x. And then now I can use my calculator. E to the power of 2.7, oops, 2.7, and I'm going to get x equals 14.9. Okay, let's try the next one on your own. Okay, once again, write this as log base E x plus 1 equals 1.86. So I'm going to rewrite this in exponential form. E to the power of 1.86 equals, and my argument is x plus 1. Okay, so let's do this. E to the power of 1.86, and I get 6.424. 6.424 equals x plus 1. Right? And subtract 1 on both sides, I get x equals 5.42. Okay. So I'm just going to walk through this example. Here's another way of doing this. We can say, okay, so we can do something called taking the log on both sides. So I can write this as log 2 to the x equals log of 10. Okay, and then I can use the power rule, and the power rule is going to make the exponent come to the front, which is we just learned about the power rule. And then now I can divide both sides by log 2, and then I get this. And now I can actually type this into the calculator and watch what happens. So I can write this as log 10, close that parentheses, divided by log, whoa, what the heck? Let's try this again. Log 10 divided by log 2, close parentheses, and I'm going to get 3.32. Now, so when the base is something other than 10, this way of arranging it allows us to solve regardless of our base, whether it's 2 or 3 or 5, or it doesn't matter what the base is. So I could also do the same thing by doing natural log on both sides. So instead of log, I could have put natural log on both sides. So like in this example, they did natural log on both sides of the equation. Then they did the power rule to bring the 2x to the front, like we did here. And then they divided both sides by natural log 3, and then multiplied both sides by a half. So let's do that. So natural log of 20, close parentheses, divided by natural log of 3, close parentheses, and I get this number, and then I'm going to multiply that times a half times 0.5, and we get this answer that they got here. Now, like I said, it doesn't matter if I do log or natural log. Let's try it with log. Log of 20 divided by log 3. And notice I'm going to get 2.726. But it didn't matter if I did log of both sides or natural log of both sides because it doesn't matter. Okay. So I hope that was useful. So now I want you to try these on your own. I'll do a couple with you, and then I need you to try these on your own. So first one here, log on both sides. So log 2 to the x equals log 5. Okay, so now I'm going to use the power rule, and I'm going to say x log 2 equals log 5. And now I could divide both sides by log 2, and x equals log 5 divided by log 2. And so typing that into your calculator is so log 5, close parentheses, divided by log 2, close parentheses. So if you are not careful with closing the parentheses, then you'll get something totally different. And your answer here is 2.322. Okay. Okay. So you need you to hit pause and try some of these. I guess you don't need to do all of them, but I want you to give some of them a try, because once you do a few of them, you'll have the hang of it. But sometimes people need extra practice. So here are the answers for these. I hope you noticed the process. Now notice here, I could have done log or natural log, but for I and j, you want to do natural log, because you know natural log of e is 1. So it's a little simpler for questions I and j. Whenever you have e to a particular power, you're going to want to do natural log on both sides, not log. But you will still get the answer if you did log. But okay, so let's do number 2 problems now. Okay, so same process. Log 2 for x equals log 9. Okay, I'm going to bring the 4x to the front using the power rule. 4x log 2 equals log 9. And then to solve for x, I'm going to divide both sides by log 2 and by 4. So I'm going to have log 9 divided by log 2, and then we're going to divide it by 4 or multiply by 4. And then we're going to get, let's do this together, log 9, close parentheses, divided by log 2, close parentheses, and then divide by 4. And you should get x equals 0.712. Okay. I want you to hit pause and try to do a few of these yourself. Okay, now you're ready to check your answers. Here are the answers for these problems. Okay, so some of the A, B, and C should be the same on your page. D, E, and F. So I guess the G and the H is not in your handout. I don't know. Okay, I guess I took off G and H because I thought it was redundant and too much. Okay. Now we're going to do some word problems here. Okay. The radius of R of a fungus on a tree has this equation. Okay. T is the amount of time since the fungus was first observed. State the radius of the fungus when it was first observed. So when it's first observed, T equals 0. So if I rewrite this with T equals 0, I'm going to have R of T is equal to 5 times 2.4 to the power of 0. It doesn't matter what K is if T is 0. So this is all going to be 1. So the answer is 5 centimeters. Okay, after 4 days, the radius is 8. Find the value of K. Okay, so if I plug in 4 in for T, okay, so I'm replacing T with the 4, and they just said that this value is equal to 8. So I'm going to say, okay, so when so now I've got 8 equals 5 times 2.4 to the power of 4k. Okay, so the first thing I think we should do is divide both sides by 5. So I'm going to divide both sides by 5. Okay, I can't divide by 2.4 because that has that power, and we can't do that. So 8 divided by 5 is going to give me 1.6. 2 equals 2.4 to the power of 4k. And now we're just going to practice what we just did on the previous page, where we're going to do log on both sides. So I'm going to say log of 1.6 equals log of 2.4 to the power of 4k. So we just took this equation and we did log on both sides of the equal sign. Okay, so now I'm going to use the power rule and bring that to the front. So now I've got log of 1.6 equals 4k log of 2.4. And remember what I said earlier at the beginning of this video is when you're solving for the exponent, here we're solving for k, that's why you convert and you change things to log, so that here we're using the power rule to bring the exponent to the front, and then now we can solve for k. So now we're going to divide both sides by 4 and log 2.4. So we're going to get k is equal to log 1.6 divided by 4 and log 2.4. We're dividing both sides by 4 and log 2.4. So I can type that into my calculator. Log 1.6, close my parentheses, divided by 4, divided by log 2.4, close the parentheses, and we get 0.134. Okay, and then question C, how long will it take for the radius of the fungus to be 10? So, so we've got our function. Right, that's our function. We know k is this decimal, so I'm going to say, and we want the final value here, we're going to replace this here with 10. So we get 10 equals 5 times 2.4 to the power of 0.134t. We're trying to solve for t. Okay. Okay. First thing I'm going to do is divide both sides by 5 to make that go away. And now I've got 2 equals 2.4 to the power of 0.134t. And now we're going to do the same process. We're going to do log on both sides. Log 2 equals log 2.4 to the power of 0.134t. And using the power rule, we're going to have that go to the front. And we have log 2 equals 0.134t log 2.4. And now to solve for t, we have to divide by those two things. I have log 2 divided by 0.134 and log of 2.4. Okay, so I can plug those things in my calculator. Okay, log 2, close parentheses, divided by 0.134 divided by log 2.4, close parentheses, enter, and I get 5.91. So t is equal to 5.91 days. Okay, question 6 is super similar, and I'm just going to show the answers. Okay. All right, I hope this helps.